Ladies and gentlemen, welcome to today's groundbreaking webinar where innovation meets infrastructure and intelligence meets energy. We are thrilled to have you with us for a promise to be a powerful and thought-provoking session, introducing AI agents to energy entities and security issues. In a world where the energy sector is being reshaped by climate imperatives, digital transformation, and rising security threats, one force is emerging as a game changer, the artificial intelligence. And leading this transformation is Ecometrics, a global innovator in AI-powered solutions for energy infrastructure and beyond. Known for their cutting-edge platform Cogito, Ecometrics is redefining how energy entities operate, adapt, and defend in an increasingly complex digital landscape. Today, we are honored to be joined by a powerhouse panel of experts from Ecometrics. Dr. Matthew Harding, the CEO and founder of Ecometrics and professor of economics and statistics at UC Irvine, a visionary in AI and econometrics. Dr. Harding is pioneering the use of structural models and machine learning to drive smarter, more secure energy systems. Martin Fricker, the Chief Operating Officer with a rich background in global energy strategy and AI deployment. Martin brings a unique blend of operational insight and strategy foresight to AI Energy Nexus. Ben Westridge, a senior data scientist, specialized in predictive analytics and AI agent design. Ben's work is the heart of how Ecometrics build intelligent systems that learn, adapt, and optimize in real time. Mihai Mermezan, Director of Engineering, leading the development of scalable AI architectures. Mihai's expertise ensures that innovation is not just theoretical, but deployable, secure, and impactful. Andrei Ionete, AI security lead, focused on the critical intersection of artificial intelligence and cybersecurity. Andrei's insight will help us understand how to protect intelligent systems from emerging threats. So together, this team represents the cutting edge of what's possible when AI is applied with purpose, precision, and responsibility. So I'm giving the floor to Martin to
Thank you.
Run the show. Martin, the floor is yours.
Thank you for that very kind introduction, Victor, and to everybody in the CSA Romanian chapter, Bună seara. We are here today to cover this agenda, and let me just quickly introduce who will speak against each of these agenda items. Matt will speak a little bit about about Ecometrics, our company, and some background on the work we do, particularly in the US energy space. Then we will have Ben introduce some theory that we have applied to that space, particularly regarding the subject of privacy as it pertains to some of the analytics work we do. Then Mihai and Andre will share the next two agenda points. NILM stands for non-intrusive load monitoring, and that's a technique that breaks down aggregate energy signals into constituent parts to allow us to see how appliances are consuming energy. And we're going to combine that with how customers receive smart tips on making more or less use of those appliances. Then they are going to just quickly cover privacy in AI-driven apps. That's part of the AI introduction that Victor gave. And then at the end, I'll come back in to address any questions and invite follow-ups. We'd be delighted to get anything from the audience in terms of their interests on these subjects. So with that, I will pass it to Matt and ask him to cover an introduction to Ecometrics. Thank you, Matt.
Thank you, Martin, and thanks everyone for being part of this webinar. It's a pleasure to be here, and it's a pleasure to introduce everyone to some of the work that we're doing as a company at the intersection of data science, AI, and energy. So a few words about our company. We've been around for about 7 years. We're still a small but very much growing team. We think of ourselves as a global team, and here you have some of the experts that are affiliated with our company. And so the global nature of our companies is important to us, and we very much value the team members that are based in Romania, and they're very much part of this effort. As a company, we are structured around economics and data science, and a lot of the work that you'll hear about today is focused on the use of energy data. So you are probably aware of some of the transformations that have been happening in the energy system over the last few years. And much of that is in the realm of digitalization and the introduction of smart meters and what's called advanced metering infrastructure. So, this is a fantastic space to be a data scientist in, because we now have access to data at very, very high frequency for every single electric meter. So, in any kind of region or country, suddenly there are vast amounts of data points that can be used to build new tools and new data science techniques. So as a company, we cover a range of spaces, including data engineering, predictive analytics. We also are quite actively involved in terms of machine learning and AI tools, but we are also an economics and an economics focused company. So everything that we do is very much geared towards actionable business insights that make companies more productive. And much of the work that we've done in the energy space focuses on energy demand. So as you guys are probably aware, there are a lot of challenges right now. The world is facing increased energy demand from a number of different reasons, including the rise of AI and the need for more power for data centers. But there are also genuine challenges around how we integrate renewable resources, and how we promote a more energy efficient world around us. So some of the things that you'll hear today are just going to be some ideas that we've implemented successfully with various clients in the US. But we would love to hear your feedback, and hopefully there will be some interest in Romania and in Europe as well in terms of what we have to offer. So with that, I'm going to hand over to Ben, who's going to introduce one of the main challenges that we have in this space, which is, given the amount of data that we see on individual customers, how do we actually design products that are focused on privacy at the same time? So with that, Ben?
Yeah, thank you. Good evening. So I'm just going to start with the basics of all of this and explain exactly what we mean by privacy by design. So this is a framework that flips the traditional model that we normally use on its head. Instead of just bolting our privacy designs onto a system after it's built, which, if we're being honest, is usually in response to a complaint or a breach, we're going to make that a foundational design goal of everything we do. This concept has been around since the 1990s, so much so that it's even being incorporated into a lot of regulations like the GDPR, the CCPA in California, and then even the CPUC's privacy rulings for the utility space in California that just recently came out. But it's based on these 7 core principles, and I'm going to highlight a few of them here for you. We're going to go over 4 right now. The first, I think, that's really important is that this design system is proactive and not reactive. We want to prevent there from being a breach or an issue instead of responding to it. So we're gonna spend a little bit of time up front making sure that there's no future issues instead of figuring out later on how to mitigate them. Second is that privacy is the default in this design. We don't have to take extra steps to protect data. They're naturally protected. In fact, we take steps to expose data for usage instead of taking steps to protect it. It is by default protected. And then third is end-to-end security. We do security from the collection all the way through, the end state of the data, which is deletion. It is protected the entire way. The last bit I wanted to talk about here and spend a little bit of time on, though, is the idea of full functionality. I think that there's this idea that there's a zero-sum trade-off between privacy and usefulness. And I hear people say that all the time. We were just at a conference where people were talking about that, which is that the more there's privacy, the less functional the data becomes. The more security, the less data access or innovation that can happen. And it has this implicit translation in business, which is if we protect our customers, we lose value. And that's not true. That is not true. It is possible to maximize both privacy and utility through technical and architectural designs that we'll talk about right here. So what does this look like in practice, right? So this is a simple flow chart, just kind of talking through it. This represents an end-to-end pipeline that could apply to any sort of data, whether it's utility data, financial records, healthcare logs, any system dealing with sensitive or personal data. It starts with secure data ingestion. That means encrypting data in transit, verifying device identities, and limiting data collection only what's necessary. This can kind of be tailored to the specific use case on how much this needs to be protected in data ingestion, or at what stage the company actually gets it. The next stage would be staging and pre-processing, where you can pseudo-anonymize the data, validate it, and normalize the incoming data. At this stage right here, there's no analytics specifically happening. This is making sure that we set up a clean, secure foundation. Then comes kind of the heart of all of this, which is the privacy preserving transformation layer. That's where you see more elements here. We apply a toolkit at this stage, which starts off with de-identification and aggregation for early filtering. That's on the far left side. We can use differential privacy to add mathematical privacy guarantees to aggregates or queries. This can have a local or global privacy maximum. So we can say, okay, out of all of this data set, we have a maximum privacy allowance. This prevents leakage attacks. This is an extremely important idea that within all of these data aggregates that are getting published, that a linkage attack is not possible. And I'm sure with this group, you guys have seen a lot of this kind of happening and similar things now. This is like a common tactic that people will use to compromise information. The differential privacy pretty much completely can eliminate that. Next is synthetic data generation, which is where we can create safe, shareable data clones. This is really important for innovation. We'll talk about this in a little bit. And then federated learning, secure multi-party computation, and homomorphic encryption, which I just put all under the secure multi-party computation. That is where, with the federated learning, we can train models across decentralized sources without moving data, since a lot of times moving data from one location to another is dangerous for the data's integrity or security. The multi-party computation allows us to create statistical models without anybody revealing their inputs. So we can share across companies or locations without actually any of the inputs being exposed to anybody else running computation on the data, but robust models can still be made off of them. And then the strongest one is homomorphic encryption, which allows us to encrypt data and then perform analytics on it with it never being decrypted. Now, this is a really, really powerful tool that doesn't have to be used in all cases. And in fact, one of the strengths of this system is that we can choose which of these tools is most beneficial for the use case and the data that we currently have. So we layer on here in the middle, role-based access control. Different users, I just say like internal analysts, external researchers, regulators, and auditors, for example, they get access only to the level of detail and only the data that's appropriate for their role. Everybody gets what they need to do their job, and they don't get anything more. And then we can visualize insights and report that out, but only from the data that's been carefully transformed and governed so that those visualizations and insights protect the consumer's information. This is what privacy by design looks like when we implement it end-to-end. A system where privacy is part of your data flow and not just a policy document that sits somewhere whether or not it's implemented. This is encouraged from the very beginning that the privacy is enforced internally. It's not something that has to be later on, like a user-based system where we just hope they follow it. Next slide. And so we'll finish it up kind of with this, and to tie it all together about this intro to what this is. Why should we care about all this? What's the real world value, and how does this really affect my company? And so I'll start with the obvious, which is compliance. These, different compliance things that I listed, they don't just require privacy. They increasingly expect it to be embedded into the system. The privacy by design helps meet that bar structurally, not just legally. So we are past the stage of just the pure letter of the law compliance. This guarantees that it cannot be violated. The next is trust, which is that consumers, regulators, and even business partners that work with you are going to be asking, what are you doing with my data? When you can point to one of these robust built-in internal architectures, that builds confidence between you and your partners. Next is innovation. There's these privacy preserving techniques allow you to share data with researchers, developers, third-party vendors, and even internally at different security levels without compromising security. That unlocks a lot of use cases like cross-institutional benchmarking, collaborative AI model training, and regulatory reporting with privacy guarantees. And finally, there's this strategic element of alignment. Companies that treat privacy as a first-class design goal aren't just avoiding the risk, they're gaining a competitive advantage with the people that don't. They can move faster, share more data, and do it without compromising values. In fact, this data sharing can be sped up internally, and that what data can be shared and not shared already. It doesn't have to be a case-by-case basis. This isn't just a checkbox or a check-the-block kind of model for compliance. It's an operating model. It's one that future-proofs your systems to enable responsible innovation and earn trust over time with all of your vendors and customers. All right. And that's it for that slide. Next slide.
Okay, then, so Ben set it the context as a principle in the development work that is done in the space and within our teams. Now, as Matt and Martin mentioned at the beginning, there are a lot of behavioral insights built on top of the AMI infrastructure. So my part here will present a brief introduction in some use cases that build on top of the AMI data and how we generate valuable insights based on that. We'll focus on the technical aspects and some general understanding of the programs here. So one really interesting use case in the energy space nowadays is behavioral demand response. This is actually now subject to a legal framework development at the European Union level as well. So every single government in the European Union will have to implement its own legal framework for this. Namely, you might be familiar with the demand response programs. So you do want to stabilize the grid to have a load demand equilibrium for each customer, namely industrial customers, but also households. And while for the industrial customers, there are a lot of rigorous processes in place with sensors and remote demand response, remote control. For the households, you have greater granularity in terms of the customer base, but less control. Here, the behavioral demand response imply that you have to send signals to customers based on their profile in order to model their behavior. One thing supporting this, so we'll call it customer profiling, which has multiple components. The customer profiling attributes a data DNA to each of the customers with information that ranges from demographics to how they use their appliances. Here we have several strengths in developing this kind of models. You can see disaggregated usage here for a EV user that stopped using an EV. In the left side of the figure here with blue, you have the EV usage, and then you can identify the moment when the customer stopped using a specific EV. We'll dive deeper into how this works, but the main point here um, is that knowing you cannot control what you cannot measure. So developing this data DNA model enables us to have control over customer behavior based on their usage profiles and overall socio-economic characteristics. The main use case we'll discuss today is the NILM use case, as described in the intro as well. So non-intrusive load monitoring means disaggregated usage over appliances. The literature created four categories based on the signal signature of each appliances, from Boolean appliances like light bulbs to more complex systems as photovoltaic systems. Our focus is mainly on type 2 and type 3 devices. The history of disaggregation, as I said, we're trying here to spark a light inside the geek inside everyone's heart. I hope that's the case for the attendees today. And if not, just blame me for picking this topic. But the progress of disaggregation at household level is in line with time series processing. We have a foundational work in the 90s based on clustering mainly, and then it evolved in line with the AI field, so to say. It evolved with statistical models. They developed standardized data sets in mainly US, India, and the UK. That are some of them are outsourced, some of them are still just for commercial use. Then, of course, convolutional neural networks and recurring neural networks that reached an impressive level of accuracy for some specific context. But again, this was highly dependent on the demographics. Now, in line with the recent advances, we have transformer-based architectures for disaggregation. We have the foundational informer model that has the sparse self-attention mechanism. As you know, transformers were mainly used for the natural language processing applications. Then we have this adaptation for time series in informer, and then energformer is the tailored version for the energy space. The NILM, as I said, is developed in the research area mainly for the industrial environment, and one of the most distinctive features in NILM is the initial boot up signal. So you can see in the plot here some different appliances and their initial boot up signal. At household level, how this is regulated in the United States and also in Europe. At household level, you have this 15-minute sampled data at scale. So you need to define different features, as you cannot treat it as a pure signal analysis project as for the specialty literature, but to involve more macro level data and retraining on specific features and custom defined features. So there is an overload with a lot of not so technical features, like we're using commercial or billing data to build up the general framework for this. And overall, we display this sort of disaggregated usage, as you can see for the solar production, the daily cycles, and so. And then in the bottom side of this chart, reduced dimensionality for clustering. After putting all the features together, we reduce it to a bidimensional space and plot it in order to have an initial version of customer segmentation. This can be used in purely technical projects, as in NILM. We extract features over how we display this data, and also in commercial and marketing projects, as well, as if you define customer categories based on their usage patterns. But as I said, here is more than usage patterns. It's overloaded with commercial information as well. You can have more targeted programs for marketing and offerings also. In Europe, we have quite a standardized way of contracting utilities, but this field is also evolving, powered by the smart meters infrastructure. You can have all sort of time of usage, peak demand offerings, and all of this work supports in the end this commercial sophistication that is going on nowadays. So moving forward, this was a short overview of what is powering the overall projects, and as Ben mentioned in the beginning, the AI that's secure and with this privacy by design enabled in our pipelines. We have this this next step of aggregating all of the customer profiling data and enabling the overall interaction with the end user. And for this project, I'm passing the torch to Andrei, that's leading the AI security efforts on our end. So Andrei.
Thank you very much. Okay, so my aim today is to show how some principles that govern data utility privacy can be applied pretty much plug and play to AI, and in this case, conversational AI. So I would like to reiterate something that Ben said, and it surprised me that we were thinking alike, that when people talk about AI and data privacy, they do indeed think that they're mutually exclusive most of the time. So they think that you either get smart AI that can really help you with your tasks, or that you can get privacy, but never both. Well, today I want to show you how we've managed to build an AI platform that proves this wrong. And we did this using these five fundamental privacy pillars, as we like to call them, that we managed to boil down our procedures to. So these would be some of the elements that Ben already went over. And the main idea is that these aren't just theoretical concepts. They're battle-tested principles we've managed to implement successfully in production for our customers that get data handled by us, and it's sensitive data. So going forward, as I said, we'll see how these same principles can be applied to AI, and where our approach at some points goes a bit beyond traditional methods. So we tried to identify the core challenge and the data type that we were working with, and then seeing how we can implement privacy as we should. So where most companies collect everything first and then try to protect it later, we tried to be proactive, just like Ben said. We created what we call in our application a privacy firewall, and that means that critical information never really enters our backend infrastructure at all. It's it's being stopped at the gate, so to speak. So this is done using a filtering in the front end, and then the data itself is being stored in a multi-tenant vector database. And then the last thing we're doing is to summarize that conversation. And in the next slide, we will break down exactly how we achieve each of these steps. Okay, so when it comes to front-end PII filtering, what we mean by that is that we use a comprehensive regular expression-based scrubbing before our backend receives any piece of information. And in order to be truly performant, our regex patterns are intentionally over-inclusive. So that is because we'd rather remove something that might not be a PII rather than risk letting actual PII through. Our second procedure, or rather element, is our multi-tenant isolation. It's a physical separation of user data in vector database partitions. And what this ends up being is, rather than each user getting their own partition in our database, it's like having separate buildings for each customer's data, not just separate rooms. Then our conversation summarization is an attempt to make the LLM itself into a privacy tool. We're trying to make it understand that we want it to forget the details and just get as much info as it can get in order to be useful. So let's say that John said that his bill was $200 and he was asking why. We do not store that. We actually store the fact that the customer discussed his billing concerns. And our last, but not least, method of privacy discussed here is our session-based access. And this means that our architecture ensures that you can only access your own data at any point in time. Now, I would like to now draw some parallels. I said that there are direct parallels between the framework that was being showcased in the paper and earlier on and what we've been doing. So that is because we have discovered that good privacy principles transcend industries. And whether we're protecting smart meter data or in this case, chat conversations, the fundamentals largely remain the same. For instance, where utilities aggregate individual readings into neighborhood totals, we, on the other side, filter PI and summarize conversations. So sort of our goal is the same. It's to collect only what's needed. Next, we use limitation in practice. So where the utility world uses privacy engines to control data access, we use this multi-tenant isolation, and that ensures that everyone only uses what they're supposed to. So again, different implementation, but the same principle. And privacy by design is the base of all this. It's the idea that, again, as Ben said, privacy and security should be built from the ground up with the application rather than being an afterthought. Okay, so now what our platform does to ensure this privacy. So we talked about this conversation summarization and why we see it as privacy as a privacy strategy, the idea is that we're essentially teaching the AI to forget the details while remembering the context. So users do get continuity in their conversations without us storing verbatim transcripts that might have sensitive data. It's like having a smart assistant, but with selective memory. And again, this multi-tenant vector architecture really stands at the base as really is the backbone of our application, because while some traditional approaches might use complex cryptography to separate the data, we chose that physical separation I talked about earlier. It's simpler, it's more reliable, it's actually more secure, and it comes with the upside of actually being a bit more performant as well. So now my last slide will be sort of what we've learned from trying to actually implement all this. So the first thing that we learned was that privacy boundaries matter, and they matter a lot, because the earlier we implement privacy controls in our data flow, the more effective these are. So in our case, the front-end filtering prevents problems that back-end solutions can only mitigate or bypass. Then the data lifecycle should be kept in mind in all its stages. So we shouldn't just think about collection and analysis. We should think about the entire lifecycle. So maybe questions like, how does our data age? Or when should it be summarized or even deleted? And the third one is trust architecture. It means that clear trust boundaries make privacy easier to implement and verify. So multi-tenant isolation is simple to audit and explain, and very efficient. And the last one, regulatory alignment. Privacy isn't just about compliance, it's about building systems that can adapt and can grow and can remain on top as regulations evolve, as they keep doing.
So I'm going to jump back in. Thank you, Andre. Just for some perspective on what we've delivered here, I've been feeding some inputs in on the chat with some links to ecometrics information, and I very much encourage anybody who's listened today and feels there's a subject there they'd like to follow up on. Please follow those links, or indeed just reach out to me via the contacts on this slide. But in addition, let me just give a perspective to some of the things you've heard. We sometimes think that California, we're lucky enough, some of us, to live here in California, is kind of like the epicenter of the world in terms of energy and perhaps AI use more generally beyond that industrial sector. But we've actually met folk, we won't name them, who actually are C-level people who have actually banned AI within their companies. And they've done so on the basis of fairly, it at least seems to us, shallow impressions that they formed on the basis of things like ChatGPT. Ecometrics is not necessarily focused on only conversational AI. We seek to engage on much deeper machine learning. And we believe that these techniques and this science can actually help those utilities break new boundaries. But as you can see, if C-level folk have taken those sort of positions, and primarily because they are concerned about privacy, data privacy, then there is a journey still to be taken. And that's here in California. That's not talking about some of the challenges you may be seeing in Romania or some of the countries that CSA's chapters represent. So anyway, with that, I would like to invite any questions from the audience. And if they're not forthcoming at this time, again, Mihai, if you could just quickly put back up the slide with my details, please send them on to me. The idea here is to encourage some engagement and some awareness in the Romanian chapter of CSA And certainly Andre and Mihai would be delighted to engage locally on those matters. But if there's something that you want to discuss with more with application beyond the boundaries of Romania or Eastern Europe, please reach out to me. I'd always be very happy to help and entertain that interest. Matt, would you like to just say a few final words?
Thank you, Martin. And thanks everyone for listening in. And I know probably many of you are going to be watching this offline. So I just want to sort of reiterate our commitment as a company to expanding and hiring new talent in the space of data science, AI, and also energy. So if you are watching this and you think this might be the kind of work that you are interested in doing, please feel free to reach out to Martin, because, even though we may not have an opening right now listed on our website, we are hiring on a continuous cycle. So there might be opportunities available with us. We are very, very happy with our talented engineers and data scientists in Romania, and they're very much a central part of our team. We work across many areas and time zones, but I think we are a very cohesive and very forward-looking team. So if you think this is the kind of work that interests you, don't be shy. Please feel free to reach out to us, and we'll be happy to have a conversation with you. So thank you very much.
I'm just going to jump back in because I know, Victor, that the audience also encompasses academic entities, and I just want to have a quick word for those guys. We have started to engage with some projects in Romania with the academic community, and again, very interested in further engagement to that end. And then into the sort of non-academic audience, clearly, if you see something in the presentation today that intrigues you for practice in business or within your organization, again, we are always very happy to engage and talk and listen and see if we can find some unique solutions to common pain points. So again, please reach out if there's anything here that really interests you or engages you. And thank you. Back to you, Victor.
Thank you. Thank you very much, Martin. So I saw the entire presentation. What you have done, guys, is really impressive. I'm from the banking sector, and I'm really thinking how this work can be also extended beyond energy and energy systems. So because privacy is everywhere, so we can think about this way, and yeah, I will have a closer look on the papers, and I will come back. Maybe we can think about building up some interesting ideas.
We'd be delighted to engage on that, and I think you're absolutely right that privacy plays a major part in the industry you've referred to. It does in others, and we think that's a very good use case for the type of techniques that we've outlined today, and I think can be made applicable to that space. Thank you, Victor, for that input.
Okay, so thank you all for joining us today. So until next time, take care and stay inspired. Have a great evening, and see you. Bye-bye. All the best.
Goodbye.